Hi guys, welcome back to day 2 of lesson 4.3. We are going to continue to talk about transformations of absolute value functions. So today you will need the lesson 4.3 day 2 note sheet, which I posted on Google Classroom, and you'll also want a pen or a pencil. And today we are going to identify transformations just like last time, but some different transformations this time. And then we're also going to graph those. Okay. So big things to remember from yesterday. We have this H value, which if you remember is going to move your function or your absolute value left or right. And then we have this K value that moved it up or down. Okay. So the H value was inside the absolute value bars and the K was outside at the end. And then what we're going to learn about today is this A value and what that does. And that's out front. That's like being multiplied by the absolute value. Okay. A couple of other big things to remember from yesterday is that the absolute value function has this V shape. Okay. And it's also super important to remember that it starts at 0, 0. So that is like the point of the V or the origin. Is at the origin. And then you also want to remember that the slope goes up 1 over 1. Okay. So slope is up 1 over 1, up 1 over 1 on both sides, or on the right side. And then on the left side, it's just mirroring that. Okay. So those are going to be important pieces of information as we move forward today. Okay. Then the other transformations that we're going to talk about today are reflections, which produce a mirror image of a graph over a line. In this case, it's mostly going to be over the x-axis. And then we're going to talk about vertical stretches and shrinks. And then there are also horizontal stretches and shrinks, but we're not really going to mention those too much. Okay? All right. So moving right along here. Vertical stretches and shrinks and reflections. So that is what the A value does out front of the absolute value. And if that A value is greater than 1, so let's say it's 2 or 5 or 10, whatever it is, if it's greater than 1, it's going to be a vertical stretch, we are going to call it. And what a vertical stretch will do is it will make your graph skinnier. Now, I know that sounds weird because we're talking about stretching, which you think makes it bigger, but then it says it'll make the graph skinnier. But think about really pulling, we're talking about vertically. So really pulling your graph up and down, it's going to make the V skinnier, okay? Then the next part says if A is between 0 and 1. So those are mostly going to be fractions. Oh, yikes, the writing today. So fractions meaning like 1/2 or 3/4 or something like that. So if that is the number out front, then we are going to have a vertical shrink, okay? And this will make your graph wider, okay? So you want to think of that. The stretch is like pulling, okay? Oh, and the shrink is like pushing, where you're almost going to like push it towards the x-axis and make it look wider, okay? And then the last option is if your A is less than 0. So basically this means if it is a negative. Okay, so if you have a negative number, that means that it's going to be a reflection over the x-axis. So think about that. A reflection over the x-axis looks like this. Okay, makes sense. And let's think about if it were over the y-axis. Well, if you flip that over the y-axis, it looks exactly the same. So that's why we're not really going to worry too much about reflections over the y-axis. We're just going to focus on reflections over the x-axis. And it's just going to make the graph flip. Okay. let's keep moving. So in this part here, and you may want to look at these notes, but in this part here, it says identify the vertical stretch, vertical shrink, or reflection from the equation of the graph. So in this case, we have a 2 out front. So that right there is going to be a vertical, and I'm going to kind of shorten that by just putting B. But that is going to be, it's a whole number greater than 1, so we're going to call that a vertical stretch. And you also need to say by what factor. So we're going to say a vertical stretch of 2. Okay, because of that 2 out front. All right, then the next one, we have that 1/3 out front. So that's going to tell us it's a vertical shrink because it's a number between 0 and 1. It's a fraction. And that vertical shrink is by a factor of 1/3. Okay. So for part C, I want you to go ahead and answer that. And hopefully you got that negative out front tells us there is a reflection, and that 3 tells us there is a vertical stretch of 3. Notice I didn't say of -3 because the negative is the reflection piece. Okay? Awesome. Let's keep moving. Let's take a look at these 2 graphs here. And in part D, we have to determine if it's a vertical stretch or shrink, and if there's a reflection or anything like that. So in part D, I can tell if I were to actually draw my parent function on here, remember that starts at 0, 0, and that goes up 1 over 1, up 1 over 1. Okay, so I would reflect that here. And I can tell then that this graph has gotten skinnier, right? So I would say if it's skinnier, that is a vertical stretch. But by how much? And really, in order to figure that out, all you really have to do is figure out the slope. So I've put these red dots here to help you figure out the slope, but this one goes up 1, 2, 3 over 1. So this would be a vertical stretch of 3. So then if we were to write that as an equation, we would know, okay, that would just be y equals 3 and then the absolute value of x. Okay? All right, same idea. I think it's helpful if you first see the parent function. And so this one looks wider, and it's also flipped over the x-axis. So I know that there is a reflection here because it's flipped upside down. And I know that there's also going to be a vertical shrink. Okay. So we just need to figure out a vertical shrink of how much. So again, we're going to just measure the slope, which it has moved down 1 and to the right 1, 2, 3, 4. So this would be, we don't have to say the negative because we already know the reflection is the negative, but it would be of 1/4. And if we wanted to write this as an equation, we would write it as y equals, and we would put the negative for the reflection, and then we would put the 1/4 for the vertical shrink, and then the absolute value of x. Okay, and that would be it. All right, let's keep moving. So far, we've been given an equation and we've been given a graph, but now let's actually try graphing it. Okay, so first thing I'm going to do is again put that parent function here so we know what that looks like. Okay, then what I want to do is talk about what the transformations are. So I know that there is a reflection here because of the negative. And I know that there is a vertical stretch by a factor of 4 because of that 4 out front. Okay. So my next thing I would do is figure out with that 4 what the slope would look like. So I'm going to go up 1, 2, 3, 4 and over 1. And this is what my new slope should look like. Notice my origin didn't change, just my slope did. So it's a skinnier V shape now, okay? Now, I didn't account for the reflection yet, so that's the last part I need to do. And all I'm going to do is literally flip that. So the origin still stays the same place, and I need to go, instead, I'm going to go down 1, 2, 3, 4 over 1. And this is a reflection over the x-axis. So this green one would be my final answer, okay? I know it's kind of confusing with all of these drawn in, so if you want to, you could erase that, okay? But the green one is your final answer. The red one was your parent function, y equals the absolute value of x. The blue one would just be y equals 4 times the absolute value of x. And then the green one is y equals the negative 4 times the absolute value of x. Okay? All right, cool. So now let's try to put all of that together, what we did yesterday and what we did today. Okay? So remember, we have vertical stretches or shrinks, we have reflections, we have movements left or right, and movements up or down. Okay? So first thing in 3 is talking about identifying the transformations, and that negative out front tells me there is a reflection. And that +3, if you remember back from yesterday, +3 is actually going to move your graph to the left 3. Kind of the opposite way of thinking. Okay? In part B, the 2 out front tells me vertical stretch of 2. And that -5 tells me down 5. Okay? I would like you to try part C. All right, there are quite a few transformations here, so hopefully you got them all. The negative means there's a reflection. The 1/2 means there's a vertical shrink of 1/2. The x minus 4 on the inside means you move to the right 4, and the +7 means you move up 7. Okay, then opposite way here, now we are given the transformations and we have to come up with the equations. So first one, A, should look like y equals, the reflection tells me there's going to be a negative, and then if we want to move to the left 6, that's going to have to be inside the absolute value bars and x plus 6. Okay. Part B, there's a vertical shrink of 1/4 and it moves down 2. So that's going to look like y equals your vertical shrink, which is 1/4. And then your absolute value. And then there's no movement left or right, so you're going to end that. And then down 2 would be a -2 at the end. Okay, and next one. A vertical stretch of 2, a reflection, and right 7. So again, reflection goes first, vertical stretch of 2, and then right 7, whoops, would look like x minus 7 inside the absolute value bars. Okay, so again, go ahead and try your own here. And this one should look like y equals a negative because there's a reflection, 5 because of the vertical stretch, then the absolute value bars, x minus 2 because to the right 2, and minus 9 because down 9. Awesome, let's keep moving. Last part is graphing, so putting it all together with graphing. And again, I'm just going to include my parent function first for all of these. I'm doing that kind of quick. But now we need to determine everything. And here are the steps. It says to first identify all the transformations, which is a good idea. It's a good habit to get into. And then next, you should plot the vertex. Okay, so we know the vertex originally starts at 0, 0, but if it moves left or right or anything like that, we need to know the new vertex. And then you're going to plot the slope on the right, so if there's a stretch or a shrink, and then reflect that on the left side. So let's see here. We have a vertical stretch of 3, and we're also moving to the left 2. Oops. Because of this plus 2. So left 2. Okay, so first thing I'm going to do after I've identified those is move my origin to the left 1, 2. Then I need a vertical stretch of 3. So instead of going up 1 over 1 like the parent function, I'm going to go up 1, 2, 3 over 1. And I'm going to graph that. And I'm going to do the same thing on the other side and mirror that. And this would be, in blue, is my new function or my transformed function. Okay, let's try part B. So that 1/2 tells me there's a vertical shrink. Oops, I never wrote 2. So vertical shrink of 1/2. And that -5 tells me it's going to move down 5. Okay, so down 5 is going to be from here, from the origin to here. And then a vertical shrink of 1/2. So that means I'm going to go up 1 over 2. Up 1 over 2. And same thing on the other side, just going the other way. Kind of mirror that. And this would be your graph. Whoops. Okay, so it's a little wider because of the vertical shrink and it's moved down. Okay, this next one has a lot of transformations, but I want you guys to try it. If you have to do it in a couple steps, that's okay. All right, so hopefully you got this. All right, so the reflection, so I can see that it's flipped upside down. A vertical stretch of 2, so I can see that the slope is up 2 over 1. And it moved to the right 1 and up 1, so I can see that by where my vertex is. Okay. Alrighty, so that is it for today about transformations. We will talk more about it in our Zoom tomorrow. Have a good one. Bye-bye.